fourth graders.
Exciting day.
It is. I know it looks a little different up here.
Yeah.
It's our experiment day.
Yes.
We're going to experiment with sound frequencies.
Yes.
And I'm really excited. But before we do that,
Yeah.
we need to do all the things we do here at the TV classroom.
Always.
First thing we do, we check in with our zones.
Okay.
Check in. How are you feeling? You can tell I can't even talk. I'm so excited.
I know.
Oh man. What zone are you in, Miss Oslin?
I'm in the green-yellow zone.
Okay.
I'm good to go. I'm focused. I'm in the yellow zone because we haven't done an experiment on TV Classroom yet.
Yeah.
And we don't know how it's going to go. So it's just kind of the unknown.
That's the thing about experiments is sometimes you can practice them, sometimes you can't.
Yeah.
Sometimes you can practice part of it, but sometimes the experiment doesn't work, but that's really part of science.
Yeah.
That's what makes science great, is that even skilled people, it might not work. There might be a
Right.
variable that didn't work for it, but it's
Right.
worked for someone else. And so you get to watch us practice all the things we teach you about problem solving and being a scientist and like trying to solve the problem. I have a feeling we'll be doing some problem solving today.
Oh, I'm sure.
And that's a good thing.
Yeah. How are you feeling?
You know, I am in the greenish yellow zone too.
Yeah.
I am in the green zone because I'm good to go. Like I know exactly what we're going to be doing.
Yeah.
But I'm in the yellow zone because we're going to be doing some different camera angles today.
Oh, yeah.
And it feels different than what we normally do. And so it's not the standard procedure. And whenever we do that here at the TV classroom, we normally run into some problems and we have to problem solve. So
Yep.
I'm anticipating that, but we left it for the last lesson to film today.
Yep.
So we weren't rushed and we
Yep.
were able to do all of it.
Yep.
Mr. Kevin, how are you? The most important question is,
important.
how are you feeling today? Because this is a lot harder for you.
Also in the yellow zone, teachers.
Mr. Kevin's never in the yellow zone.
Yes, it'll be interesting, but let's do our best.
We're just gonna do our best. And you know what? Here's what I know about us here at the TV classroom, is that when we do our best, it turns out really well.
It does.
And we work really well as a team in problem solving together.
Yes.
And because we've built our relationships in our team, we're able to kind of hold each other together and move forward. So
Yep.
you are all gonna get to experience working as a team today. And we are really excited and we're really hoping it works.
Yes. And I don't have a slide for our 3 personal standards, so we're just
That's
going to
okay.
say them from
Well, we know
memory.
them.
There
Yep.
we go.
Show respect,
Ding.
Make good decisions,
Ding.
solve problems.
Ding.
That's our big
We're
one
gonna be doing
today.
a lot of that today, and you're gonna be able to help us at home. So, before we begin, because I'm really excited.
Already.
Mr. Kevin, can you bring up our PowerPoint? And we're gonna go over our essential question that we're trying to answer with this experiment and the learning we're doing. How does sound get from the source to our ear? And we learned about sound energy, and I'm gonna put this chart up.
Okay.
You remember we did this input chart where we
Okay.
talked about how their object vibrates.
Need to hold it.
Oh,
Vibrate,
gotta
make
scoot
something
it over.
move.
back
Wrong.
and forth.
back and forth.
Wrong shot. There we go.
It's okay. I was messing it up anyway, so it's
So we learned that vibrations move air particles.
Vibration makes
making
something move.
back and forth. And then it goes into our ear, and that's how we hear. And depending on how quickly it vibrates, takes the makes the sound and pitch higher or lower. And we learned about sound waves.
Yeah, the low frequency is when the vibration makes
Making something move back and forth.
Are slow, the waves look like this.
When it's a low frequency,
And when the vibrations are fast, vibrations make
Move
something
something.
move back and forth. That's a high frequency. That's a high frequency, and those waves look like this.
and they're much closer together and much faster. So I'm gonna leave that chart here. We won't be able to see it, but it's hanging here with us to remind us.
We learned our big science word.
Ooh, big science word, Mr. Kevin.
Okay, hang on a second here. Let me find the graphic.
Big science word.
Big science word.
And can you go ahead and put this PowerPoint up, Mr. Kevin? So we
Yes.
learned about vibration.
Vibration makes something move back and forth.
And that it's we said fast movement to begin with, but remember, we revised our thinking.
We did. We had to revise our
We
thinking.
decided it wasn't necessarily fast because low frequencies are slow. And so we decided it was just movement back and forth. And we used the sentence, I can feel the vibration from the drum. Today, I think we're going to be able to say, I can feel the vibration from the speakers. Because, whew, vibration.
And
Make
hopefully,
something move back and forth.
Ooh, I didn't mean to interrupt. Sorry.
That's okay.
I didn't mean to interrupt. Sorry. See, I'm yellow zone for sure because I'm
Yeah.
tripping over my words. I'm
Yeah.
so excited for this experiment. But I was going to say you should be able to see vibration
Wait,
today.
what?
Oh.
Well, got to stay tuned for our experiment.
Oh, man. Should we go over our chant?
Let's do our chant.
Let's do our chant.
Sounds here, sounds there.
Here we go.
Sounds here, sounds there. Sounds everywhere.
Loud sounds created strongly. Soft sounds created gently. High-pitched sounds vibrate quickly.
Low-pitched sounds vibrate slowly.
Sounds from a band, sounds in nature, sounds in our world, and sounds from me. Sounds here, sounds there, sounds everywhere. Sounds. Okay,
All right.
what do we have here?
Mr. Kevin's a genius when it comes to cameras.
I know.
Look at this. Okay.
And he was so patient with us.
He was so patient. Thank you, Mr. Kevin. Mr. Kevin, why don't you come on down and help us with this experiment because you are an expert at sound.
He has a whole soundboard back there.
And he said he went to school for it. So definitely need to have him in the shot.
Definitely.
Now, we probably won't see him most of the time. He's going to run a little machine, but he's going to pop his head in and say, hi, here he comes. There he is.
Hi there.
Kevin. So he's going to run a little machine. What we have here is some speakers and a cookie sheet. And on top of it is some salt.
Salt.
Right.
And in a moment, Mr. Kevin is going to start a app on his iPad that's going to turn on some sound frequencies. And
Right.
your job is to make an observation. And we want you to write that observation down. Scientists write observations down.
Always.
And so you're going to make an observation about what's happening to the salt.
Oh, look, I'm in the corner.
Oh, there you
look,
are.
there you are.
Yeah.
What's happening to salt? And Mr. Kim will let us know if he changes the sound frequency. So when he starts it, he's going to tell you what it is and maybe write that down. And then what's happening to the salt. And then when he changes it, what's happening to the salt again. We're just making an observation right now.
I notice.
We're not asking questions, just what do you see happening? Like statements. I notice the salt is, I notice the salt, right? We're not making any guesses as why, just what you notice.
Okay.
Okay, you ready?
Yeah. So I'm going to start with a low frequency,
Okay, so we're at
And-
low on your notebook.
and I'm going to try this one here. I'll bring it up. Now that's pretty low.
That's pretty
It's
low.
pretty low.
And do we feel a vibration here?
Little bit, not
Vibration.
much.
Yeah.
It's not
Something
very,
moving back
I
and
can
forth.
feel something moving back and forth, but it's not very much.
Right.
Even on the table here, I can feel it.
Okay.
Not very. It's
Let's try a little higher frequency. I'm going to turn that one down first.
Whoa, 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 whoa! What's going on?
Wow. What do we have happening there?
I'm noticing the pile of salt is getting smaller and it's starting to move. Like you can see it moving right here.
I can feel it more on the table too.
That's pretty cool.
That is. Look at that
Whoa.
shape.
Can we go even higher, Mr. Kevin?
Sure. Let me turn this down.
You might even consider sketching a picture.
You can see that shape. And these are all vibrating.
Right.
They're vibrating and moving around.
You know what I notice?
What do you notice?
Here's a notice. I'm going to turn this down a hair. What I'm noticing is that there's two speakers underneath the sheet, the cookie sheet. And the salt is aligning itself to the shape of the speakers underneath.
Whoa.
Kind of like that magnet game where you draw And it,
Yeah.
Yeah. Okay. Want to try a higher tone?
yes.
Okay. Now that's interesting.
It's like not even, I can hear it vibrating. I can hear the salt move. There's, especially over here, I can see it moving, but barely.
I feel
But
nothing
barely.
on the table.
Nothing.
Yeah. So a higher frequency means that those wavelengths, they're much closer together.
Right, so maybe you don't feel it because they're like almost like
Right.
right next to each other, that they're so close that you can't feel the vibration.
Yeah. So let's go back to a lower one.
Yeah, there's a point at which those frequencies get so close together they just kind of
Yeah.
become one.
Yeah.
Oh, those are starting to
again.
move.
Yeah.
Whoa. Okay,
Pretty cool.
so let's stop there for a second. Let's
Okay.
have a conversation. What did you notice? What'd you notice, Miss Oswald?
Well, I noticed with the lower frequencies, the salt didn't move that I could see.
The very lowest
Very-
frequency?
Yeah.
Yeah.
Or the high, was it the highest or the
Both.
lowest?
the highest frequency, the salt's not going to move too
Yeah.
much.
And the
That's
lowest
right.
frequency, it
It
didn't
was-
really move either.
It was kind of like right in the middle.
Right in the middle.
Middle is where it started to really move. I wonder if that's like when the sound waves are kind of at the perfect
Mm-hmm.
distance apart. Well, and I've heard, I'm making a connection, but I gotta wait. We're just making
Mm-hmm. We're just making
observations.
observations right now.
Okay, let's move on to the next slide, Miss Oswald.
Okay.
Now we're gonna ask a wonder.
Ask a question. I wonder.
I'm gonna give you a few seconds to think of a wonder. What are you wondering about vibrations and sound waves?
Vibration. Make
Make
something move back
and forth. What are you wondering, Miss Housley?
Well, I'm just wondering if there, and there must be, a correlation between the frequency of the sound wave and the amount of vibration or movement that the salt showed.
Yeah, and I'm kind of on top of that. I'm wondering if when it gets so high, the frequency is so high that the vibration is so much that it like almost doesn't move. And like I know dogs can hear high frequency sounds that humans can't. So I'm wondering if there's some correlation to that. So I'm wondering
Yeah.
that. Like, is there?
Yeah.
So now we're going to do this thing called make a hypothesis.
Ooh,
If
hypothesis.
blank, then blank. So what could our hypothesis be that we can test out? Well, you kind of said it earlier, that if the frequency is in between the highest
and
and
the
the lowest, we'll get the most amount of vibration.
Yeah. If there's a certain, I don't know, like measurement between the sound waves that will create the most
Vibration.
vibration.
Now,
I
here's,
wonder if you can hear that sound the best.
so here's something I can tell you about how speakers work is that those frequencies that are very low, to be able to have that boosted in volume takes a lot of energy. So the amplifier that we have is just not quite strong enough to make the speakers really loud at that low level.
Yeah.
So a lower frequency,
Takes more energy.
Requires
to-
more energy.
more energy.
That's
to
why
make it
bass
louder.
speakers
Yeah.
are very big because they're not as efficient.
So the lower the frequency, the more energy it takes to move the air particles.
Correct.
We can hear it better.
So we can hear it better. And
Right.
so what we're seeing here is like kind of that perfect in the middle where the energy and the air particles are all moving together so we can hear it the best.
That's a great way to look at it. Yeah.
So if the frequency is really low, then it takes more
more energy
energy.
to move it to my ear.
If the frequency is high, it takes less energy to move it to my ear. So let's make a prediction. Now, here's what I'm going to tell you. I'm going to change what we have here on our sheet. So I'm going to take this little piece of tape off because we have some tape holding it on.
I'll help.
Mr. Kevin's going to help so I don't knock his speakers off the table.
Okay.
I'm going to dump the salt into my little container here. And then we're going to pour, I'm gonna, not all of it, just pour enough that it's kind of covering the bottom of it.
Water.
Perfect. Water.
Okay.
We may decide to
Water.
put more and we'll see.
Okay.
We might need to add more. We'll see if we can see it moving.
Okay. So we'll.
So
tape this
now we
back.
have water. And I'll let Mr. Kevin put this back. 'Cause
Yeah.
I don't want to touch his things. I'm just a teacher. I don't deal with sound equipment.
Okay.
Now we just have plain old water. So what do we think is going to happen? Now with salt, we noticed the really low and the really high didn't really move, but then the middle peak,
yeah.
it was like the perfect amount to have energy just to see those sound waves.
Right.
Okay, so what do we think is going to happen? What's your prediction? What do you think is going to happen with the water? What do you think, Ms. Oslin?
I think it'll be similar to the salt.
You think it will? Okay. So do you think it's going to vibrate and move, or do you think it's going to dance?
I think it'll vibrate and move.
Okay.
Like maybe we'll see like some soft waves.
Like, yeah, like I know,
Ripples-
like when you
ripples
like
through
drop a
Yeah.
little leaf in the water, it
Yeah.
makes the ripples. I'm
That's what
wondering
I
if we'll
think.
see ripples.
Yeah.
So I'll start with 20 hertz.
Okay, and that's a really low frequency.
low. Let's see what happens.
So now we're going to test it out. And can you go back to the observation slide? We're going to make another observation. Now we're going to test it with water and
Water.
observe.
Different variable.
Okay, so there's 20 hertz, and I see nothing.
Nope.
Okay, so let's stop that.
Actually, Mr. Kevin, I see a little bit of that when you stopped, like there was some movement and it totally stopped.
And it stopped. Okay, so should I go to 120 hertz next?
Yes.
Okay, let's see what 120 hertz looks like. And I'm going to bring the volume down so I don't
Blast us out.
blast everybody out.
Whoa.
Oh, cool.
On that side shot, you can really see it. I don't know if you guys can tell, but there's all these little tiny waves that we can see moving in the water.
Ripples.
You
Ripples.
can even see
just
it a
like-
little bit on the
Yeah.
straight
yeah,
down shot
you
too.
can see it.
Wow.
Wow.
Whoa.
Should we try any higher frequency?
Yeah.
Okay, let's try 220 hertz and see what that looks like. Now this one's going to be a little louder, so I got to bring the volume down.
Yeah.
Because remember, the higher frequencies are more efficient through those speakers.
And that might
Requires
damage our
much
eardrums
energy.
because it's
right. If it's too
easier.
high, yeah.
Yeah.
Okay, here we go.
Oh, it's starting. I'm seeing it.
Oh, I noticed it took us a couple seconds.
Now see the waves that you can observe
They're
are
moving-
teeny little waves.
Yeah, they're closer together.
Yeah.
Can you go back to the other one?
Sure. Okay, so we're going to go back to 120 hertz
This
again.
is cool.
Ready?
Now those waves are much further apart in the water.
And they started right away.
They did.
Mm-hmm.
So those they're much further. Okay, let's do the really high one again.
Okay. So back to 220.
It did take longer, and they are so much closer.
They are.
Wow. What do you think, friends? What do we wonder?
What do we wonder?
We're not going to make another hypothesis. I'm wondering, based on our hypothesis, where we said
Yeah.
if it was lower, they were further apart. And if it was higher, they were closer together. And in the middle, like, did we do a really high one like we did with the salt?
Sure.
So we can see if it just kind of, the waves get so close it looks like it's not moving?
Yeah.
Here's 520 hertz. I'm going to turn this one down.
I kind of see.
Barely.
Barely.
Like it's just kind of fluttering.
Yeah.
I can't actually see the waves.
Yeah, I just see movement.
I see movement, but I can't see the waves. Like with the other ones, we could actually
see
see
a
the
wave.
waves.
Yeah.
So that's kind of starting to confirm our hypothesis
Yes.
that if it's lower, the waves can be so far apart that we can't see it move.
Right.
If it's really high, the waves can be so close
close
together
together,
we
you
can't
can't
see it
see it.
move. But when it's in the middle, it's like the best ability to vibrate in here, and why some people have a hard time hearing low or high frequencies because the waves aren't close enough. I'm learning so much today, friends. I'm so glad we did this
I
experiment.
know, this is awesome.
Okay.
Are we
So
going to take
now-
the water off?
Yep, we're gonna take the water off. We're gonna put one more thing on.
Okay.
Now, this is something you may or may not know about. It's called oobleck.
Oobleck.
And oobleck is just made by mixing cornstarch. You can get it in a little can that looks like this, and water. And you mix about 2 parts cornstarch to 1 part water.
Okay, so maybe like 2 cups cornstarch and 1 cup water.
Yeah.
Okay.
So I'm going to pour this extra water into the
Yep, that's what, yep.
into the little
This is our little container where we are putting all of the stuff that was
our
in there.
throwaway container.
Yep.
Okay.
Okay, now the thing about oobleck, I will show you right here, it's in my bowl. The thing about oobleck is it's kind of a mysterious concoction.
It
And
really
sometimes
is.
it's a solid, and sometimes it's a liquid. And it changes its state based on the force that is applied to it. And we're gonna apply some vibration force
Yes.
and see what it does to it. Does it do any movement? Does it stay the same? I'm gonna let Mr. Kevin tape it.
Yeah, tape it down.
And
Okay.
I'm gonna pour it in.
Ooh. Looks like pancake batter.
It
Ooh,
does,
it does.
doesn't it? Get it all. It's gonna take a second to pour in, so thank you for being patient. Now we have not tried this one. So we don't really, I researched on what might happen, but we don't know for sure. You know what I realized, Miss Oslin?
Yeah.
I forgot my food coloring drops in my bag next to my desk.
Oh, yeah.
Would you mind grabbing them? Because when we're done just looking at it like this, we're gonna see what happens with food coloring. It's almost out. But you
That's
can
like
kind
the-
of see it happening in front of us where it's the solid and then it like melts into the liquid.
That's pretty cool.
Isn't that cool stuff? There it goes. There's still some more in there. I'm gonna get it all out.
And students can make this at home how?
Easy, by mixing cornstarch and water together.
Cornstarch and water.
And depending on how much water you put in, depends on how thick it is. And then if you get it on something, what happens is you just let it dry and it turns back into cornstarch.
Oh, wow.
And so like we got a little bit on the floor, we'll just vacuum it up.
Okay.
It's next to my desk in the black bag. You see it? Where did I put my oh, it's up here, Miss Oslin. I'm sorry.
But it was fun watching Miss Oslin run around the room.
Remember I talked about my brain, or if you haven't seen
Pilfer.
it yet, in our SEL lesson, I talk about my brain, and sometimes all my thoughts go missing.
There's a lot going on right now.
There
too.
is,
There's a
and
lot
so
of
it's hard for me
moving
to keep
pieces.
it all straight.
That's okay.
Okay, I did bring it up. So I did remember, I just forgot that I did it. Oops. Okay, so now we need to make a prediction.
Oh, yeah.
Based off of our hypothesis that when the frequency is really low or really high, we can't see the vibrations, and they're actually harder to hear. But when it's in the middle, the sound waves can be closer together, further apart, but we can hear it better. So,
We have a different material that has different properties.
right, think about the salt was just these little tiny crystals, and then we had water, which we know moves really easy.
Right.
But then we've got this oobleck stuff that's a very different consistency.
Yeah.
And it also changes property when force is applied, so it can go solid and liquid.
How do you want me to start with the
We're
20?
gonna do it the same way. We're gonna
Okay.
do low to high.
Okay, let's do our 20
we
hertz
have-
here.
let's make a prediction first.
Okay.
What do you think is gonna happen? What's gonna happen when we do the low and the high frequency? How is the oobleck going to behave? What do you think, Ms. Oslin?
I don't think it's going to do anything.
You think the whole time it's just gonna stay
I
flat?
do.
She's not convinced it's gonna work.
I'm not.
All right.
What do you think, Mr. Kevin?
I think we may see some movement in that middle frequency range, the 120 hertz, the 220 hertz. I think the low frequency might be a little too much for the oobleck, and especially the speakers can't go very loud
Okay.
on the low. So let's see what happens though.
See what happens.
Okay, so here's 20 hertz. And I'm bringing it up in volume. Now 20 hertz is so
There's
low that I
movement.
can't hear it.
There's movement. Look at it, Mr. Kevin.
Very slight, but it's moving.
Oh, it's there. You can start to see just a little bit of rippling.
Okay.
You can see just a tiny, it's very slight, but there's a little bit of
So
rippling happening.
what if I did like 25 or 30 hertz?
Yeah, let's see.
Okay, let's see what happens. Okay, now I'm going to go to 20. Let's just go to 30 and
it's
see what
relaxing now. You can
happens.
see it
Yeah.
relaxing down. This is
This
cool.
is really neat.
Okay, 30 hertz. Ready? I'll start low.
Whoa, I'm starting to see like some
Bubbles?
bubbles.
Okay. Should we go up, say, to 50 hertz?
Yeah.
See what we have there? Okay. So let's go.
It's so interesting because when he turns off, it takes a second, but then it starts to relax again.
Here's 50.
It's like starting to like form this weird. Do you see that?
Yeah.
Wow. Not quite doing anything yet.
No, there is stuff happening, but it's hard to see.
Okay. Let's go on up to, let's say, what do you think? 80 hertz. See what
Sure.
happens there. Okay.
Oh. I saw some of the bubbles pop.
I did too. And It's
Okay.
starting to move.
And remember,
I'm
this is
seeing it vibrate right here.
a much thicker substance, right?
Yeah.
Okay.
But it is for sure vibrating.
Let's go up to 120 hertz.
Okay.
Go for it.
Now bring this down, stop it. And we'll go to 120 and see.
Pop bubbles. Whoa.
I thought I saw a ripple there.
I did. Oh yeah, it's rippling. It just doesn't move the way water moves.
Yeah.
It's like the ripples are like starting to form like little peaks in, like underneath here. Like you're starting to see little peaks.
Yeah. All right, now we're going to step it up to 220. Let's see what happens.
Okay.
Okay, here we go.
It's like rippled. They can't really see it. Now, I'm wondering, Mr. Kevin,
Yeah?
do you have any music on there that we could play? Do you think?
I don't have music on
On that
this.
one? Okay.
Yeah.
So I'm wondering, like, if the change,
Yeah.
like the up, down, would make it
More visible to
more
see the
visible
difference.
to see, because we're seeing it. Or if we add food coloring,
Try it.
if maybe the food coloring would move and we could see it.
Yeah. Now I have one more to try here, and this is
Okay.
440 hertz.
Okay.
Okay. Let's see if that made a difference.
I can see it moving. Right here? Okay. Let's see what happens.
If you add some,
Yeah.
Yeah.
Color.
We're just gonna add some drops
I'll go back down to
and see if it does anything.
220
Because those
on
drops
this
might
one.
really show us some movement.
Okay. So here's
don't know, we'll
220.
Well, they're spreading out.
Yeah, they are. Look at that. Whoa.
Okay. Let's see. I want to go
And
back
then they
to
stop moving.
want to go back to 120.
They're moving again. bet if we had that stronger bass you were talking about,
Probably.
we
yeah.
could really get that to move.
Okay, here comes a high frequency.
Okay.
This is 620 hertz.
Okay.
A little loud,
Oh,
huh?
loud, yeah.
Ooh, interesting.
I certainly feel it vibrating that,
Yeah.
Uh-huh.
but I don't see
I don't see it moving.
a whole lot of movement.
We did see movement, but we didn't see as much as we were hoping for. I wonder if that has to do with the viscosity of the liquid. Like Mr. Kevin was talking about how it takes less or more energy to move that lower frequency and higher frequency sound, and this is a very thick type liquid.
So it would require more energy.
Right. I
to
wonder if
move
we like
through it.
added more water to it, if it would move better. Now the experiments I saw happen with this, they had a much stronger bass and they put music on and it actually made the oobleck dance.
Yeah.
Wow.
Which is really cool, but I don't think we have the power. So that's
don't
one of
think
the
we do.
variables we don't have
Right.
to make that happen. But that's okay. Like we can
yeah.
identify that and maybe we can at some point find something a little stronger with power
Yeah.
and test it out and just film it. We can show a little video clip
Yeah.
of us doing that. What a cool experiment.
Very cool.
This is, I'm just kind of
Yeah,
cycling
I'm wondering
up.
if you just cycle up if it'll do anything.
That's cool to hear the change.
Yeah. And the colors are definitely changing. They're vibrating and moving.
Yeah.
It's like we're taking off.
I know.
Wow.
Interesting.
Interesting.
So we are definitely going to have to try that out with a stronger, powerful
More
speaker
energy.
that has more energy.
Yeah.
But cool experience. So what did we learn today?
Here's a 60 hertz. Before we give up totally, I just want to see what that
He
looks
wants to
like.
see if he can get it to
Yeah.
do it. Oh yeah. Oh, it's moving.
Okay, well,
That's
it moved
okay.
a little.
It
did.
did move. It started rippling right here.
It did.
Yeah.
I'm gonna do some experiments at home. I have a pretty powerful speaker at home. I'm gonna do some experiments with it and see if I can get it to dance.
Very fun.
Yep, Mr. Kevin's gonna head back up to the booth.
Thank you,
take a
Mr.
break.
Kevin.
Take a quick break. We're gonna get this
Cleaned up.
cleaned up, and then we're gonna end our lesson. How cool is
So neat.
this?
So neat. You can make some cool art with that.
Oh yeah. Okay, we're back. Now, here's the thing. It didn't all go as we planned.
It didn't, and we knew it might
We know
not.
it might not. We warned you of that. And we tried to change some things to see if it would work, to see if we could see it with some food coloring, to see if changing all the different pieces, the pitch and the sound and the strength and all of that. We got it to move. We didn't get it to do what we wanted to do, which was dance and make formations, which I know it can do. So, if it's okay with your people in your home,
Ask.
do not do this on your own. You need to have an adult with you.
Did you see we both gave you the teacher mama look?
But you and an adult at your home could make this oobleck. It's just cornstarch and water. You want it pretty thick, but not too thick that it doesn't move. And you could try some sound sources at your house to see if you can get it to move. And then if you do, you could video it or take a picture and send it to us at the TV classroom.
Yes.
Now, you've done some writing with your observations today. So you could also take a picture of that. But man, oh man, what I would love to see is if students were able to do this.
To do this.
So let's talk about a conclusion we might form. Like today, we did make observations and we changed some variables, and we made more observations and we changed variables. And now we need to form a conclusion. We didn't get exactly what we wanted, but that we did not, we learned a lot.
A lot.
And that's the thing about experiments. So our hypothesis was that when the frequency is low, the sound waves are long and they don't move very much, sometimes so low that we can't even see the vibration.
And it takes more energy to move them.
And when when the sound waves are higher, sometimes they get so close together we also can't see
Yeah.
it move. And in the middle is kind of the perfect where we can hear things because the vibrations are far enough apart but not close enough together. Did that happen for us? It did with the salt. It did with the water. It didn't with the oobleck. But we were thinking that this is a lot thicker, so maybe it wasn't powerful enough. So I think we're on the right track to how sound moves and how it might get from the source to our
my
ear. Right about that. Yes, Mr. Kevin?
Something for the students to think about is that the problem we experience today is kind of like if you push a toy car, you can push it very easily. Now, get behind your mom or dad or adult's car and try to push that.
Oh.
Yeah, a lot harder to push, right? It's a lot harder to get it to move.
You need more energy
More energy.
to move larger things. And the starch, the cornstarch oobleck, is a larger thing to move than the salt or the water.
So, if you want to test it out, go for it. Or write about what you learned today, or what you think might happen, or how you think you might solve the problem we had today. And then send that in to us at the TV classroom. Mr. Kevin, how can they send us a video or they're writing about what they think we could do to solve the problem?
So you can send a video by putting it in an email as an attachment. It should be an MP4 file. Send it to TV Classroom at tacoma.k12.wa.us. And if you want to mail us something, you can always send that via regular mail in a stamped envelope to TV Classroom, 601 South 8th Street, Tacoma, Washington, 98405.
Awesome. Thank you so much.
Now it's time for our affirmation. We always begin with our zones. We always end with our
That's right.
affirmation. This is where we practice using some positive self-talk to build ourselves up before we go off into the world. And today, I think our affirmation should be, I can change my thinking. Because we thought we knew what was going to happen, but that's not always what happens. And as scientists, we know that it's important for us to come into an experiment or any sort of learning with an open mind, knowing I think I know, but I can change my thinking. So let's all take a deep breath together and say our affirmation. I can change my thinking. Excellent job today, fourth graders. We had so much fun learning with you today. We hope you have a great rest of your day, and we look forward to seeing you back here next time in our TV classroom.
See you later, fourth graders. Bye.
Hey kids, we want to see your work. Just send your pictures and your stories to TV Classroom, 601 South 8th Street, Tacoma, Washington, 98405.